Bilua. Thanks so much, Paris. Thanks so much, Sebastian, for having me. I'm feeling more than pleased to be here. I'm feeling privileged and honored. And but I'm definitely more happy that all of you guys are here. So thanks so much for joining this session. Now I want to get into the topic right away. So not all that long ago, I finished a book. Here it is. It's called Start With Why from Simon Sinek. And it's a great, I highly recommend to read it. And so I thought, well, it would also make sense to give you the reason why I am here today. So here's my personal why. You know, more and more I'm studying the field of software testing. It appears to me that exploratory testing is like a deodorant. And the reason for this is simple. The people who really need it never use it. And that is the simple reason why I'm here today, because I want to change that. And to do that, let me say some words about my person first. You know, in the last 10 years or so, I have worked mainly as a product manager for several tool vendors in the automation space. So I lived and breathed automation. Automation was my daily bread. It was at the epicenter of my professional life, so to say. It truly dominated my thinking. Now, all this told me one important fact about software testing. It told me to see tools as classes. So by designing tools for automation and by observing what software testers actually do, I've learned that tools do not test, just as classes do not see. So I've realized that the tools only help us to test, just as classes only help us to see. Or in other words, classes don't do the seeing, just as tools don't do the testing. So testing isn't something that happens in our tools from my naive perspective. It's something that happens in our heads. It's a thinking activity. And for that simple reason, I do not reduce testing to an act of artifact management, where you use tools to create test cases, to automate test cases, execute and maintain those test cases. Testing to me is so much more than that. And so I like to say that testing is no more about tools than, for example, astronomy is about telescopes. And if we would reduce testing to an act of test case creation and especially automation, then I think we would also need to accept the fact that when we are testing badly, automation would just help us to test badly at an accelerated rate. And this just means that we need to avoid to automate chaos. Because if we automate chaos, all you get is faster chaos, right? And this usually looks like this. Now, this is a typical software testing timeline composed of 4 phases. Now, in the first phase, I hear people saying testing. I've never heard that, right? There is only automation. We automate everything. Now, it usually takes some time until those people then start falling down what I like to call the Mount Stupid of software testing. And trust me, it's a huge mountain. But when those people then fall down that Mount Stupid, they into what I like to call the valley of despair. And in that valley of despair, I hear those people saying, okay, there is testing, and testing is probably more than just automation, but we are just not convinced that we really need it. And you know what? The last 2 phases then often look like this. So now let's zoom into those 2 phases to see what's really going on there. And now I need your imagination. Imagine that all these dots represent all the test cases you have, for example, in your regression test portfolio. And now imagine that all these test cases pass in the last regression test run before you decide to ship your product into production. And then you might conclude, well, this looks good, so let's ship it. Let's ship our software product. And that is what you then most probably will do. But just a second later, you will see something like this. You will see that repetitive test case execution, no matter if it's done by machines or by humans, is by far not enough to avoid scenarios like that. Now, this is usually the point in time where people start realizing that testing shouldn't be confused with test cases, and the testing shouldn't be reduced to the act of creating, automating, and executing test cases. So testing is so much more than that. So now let's dive a little bit deeper into that subject to understand that better. Now, to do that, I need your imagination again. Imagine that this black rectangle here on the right-hand side represents your software product. It represents the entire functional and non-functional spectrum of your software. And it also represents all the environments your software could be situated. And it also represents all the people that might use your software. So that's all there is, and that's all you could possibly know about your software. Well, the green rectangle then represents all what you currently know about your software. And this rectangle is much smaller than the previous one, because it's simply impossible to always know everything about your software down to the very last detail, right? Now, the red rectangle then represents everything you repeatedly check in your software. For example, by automated repetitive regression testing. And again, you will never be able to check everything you know at any time because of the time, resource, and budget constraints you're confronted with every single moment in your daily testing business. So the question here is, well, would it even make sense to try to automate, to codify all of your knowledge? Well, most people would say, yes, of course, that's the ultimate goal of testing, right? But I'm saying no. Because when we would only aim to automate all of our knowledge, then the question would be, well, how on earth would we be able to create new knowledge about the software? Well, the answer is we simply couldn't do that because our software constantly grows. And so you constantly need to create new knowledge about your software to reveal problems that are far, far outside your checking regime. And that is what testing, at least to me, is all about. Testing, to me, is all about closing this knowledge gap. So testing is all about closing the gap between what we know and what we don't know about our software. So the goal is rather automation or information than automation. And the reason for this is simple. A test itself is just a question you ask your software. And the purpose of performing a test is to gain information about your software, to reveal those problems. So testing always has been, and always will be, a search for information. And so I like to see testing as an information service, not as an automation service. So in its shortest form possible, I would say that the purpose of testing is to collect information to enable other people to make better informed decisions. So testing at its core is just about three things: information, people, and decisions. So first, we collect quality-related information about our software, information such as the actual or potential problems in our software. Secondly, we provide this information to other people, people such as the developers or product owners or product managers, for example. And thirdly, we share this information to enable these people to make better informed decisions, decisions such as shipping decisions or fixing decisions. So helping other people to make better informed decisions is the key here. And this is how we create value through testing, again, from my naive perspective. So now the question is, well, how do we collect this information? Well, thinking black and white about software testing, the coin of testing has two sides. And the first side is all about checking. The second side is all about exploration. And exploration always, of course, with the connotation of experimentation and investigation. So in short, checking plus exploring is testing. Now, the purpose of checking is to monitor known risks in our software. So here we constantly confirm what we already know about our software. And we either do that by repeatedly executing test cases automatically. This is what we then call automated checking. Or we perform these checks in our software by repeatedly executing test cases manually. And this is what we then call manual or human checking. So in rough terms, checking can be translated to confirmatory testing. And on the other side of that testing coin, so to say, we explore our software. And we do that to analyze potential risks. That means problems that might happen in our software. And here the goal is to collect new information about our software. And this is what we then call exploratory testing. So the bottom line here is that testing is a good mix of creative exploration and, I would say, mechanical confirmation. And these activities, from my point of view, are, kind of boson buddies in software testing that enable us to learn more about our software. So let's dig a little bit deeper into those activities, and let's start with checking. Now, according to Michael Bolton, checking, as depicted here on that slide, is the process of evaluating software by applying algorithmic decision rules to specific observations of the software. Now, this simply means that when you check something in your software, you operate your software algorithmically. So you mechanistically follow predefined step-by-step descriptions that are, for example, contained in your test cases. And you do that to check certain facts about your software. So in simple terms, this means that through checking, the goal is to answer the question, does this assertion pass or fail? And to answer this question, you make one or more checks. And the check then always provides a binary result. Let's say in terms of either true or false, yes or no, on or off. Now, instead of answering the question, does this assertion pass or fail? Well, you're trying to find an answer to another question. The question is there a problem here? And you do that during exploratory testing. And this is a much bigger question. And this question usually has no binary answer. Now, even though this is just a subtle wording difference, the process of answering the question, is there a problem here, asks for a completely different testing mindset. Since that kind of decision, requires the application of a variety of activities, such as questioning, studying, modeling, making inferences, among many, many others. So exploratory testing is truly a way of thinking much more than it is a body of mechanical checks you perform. So checking is something we do with the motivation of confirming existing beliefs, and exploratory testing is something we do with the motivation of finding new information about the software. So now let's dive one level deeper into these activities to quickly assess how much of testing can be automated. And let's do that by asking two simple questions. First, what needs to be done before you can even check something in your software? And secondly, what needs to be done after you have performed the check? Now, before you are even able to check something in your software, well, you must learn about your software. You must learn about the domain in which your software is situated and the value, for example, it provides to the stakeholders in that domain. Now, here already, you need to step outside your software and think about how your software intersects with people. And this means you need to analyze your stakeholders. And you do that by studying your software and everything, literally everything that surrounds your software, such as the people, the business domain, or the technical environments. And your learnings will then help you to create models of your software. And you keep doing that to create better and better models of your software. And these models will then help you to understand your software. For example, to understand the intent, the purpose of your software. And this then enables you to recognize, identify, and most importantly, to prioritize risks in your software. And then you translate these risks into test ideas. And then you express these test ideas to questions. And then you refine your questions to one-bit yes or no questions. And then you algorithmically describe how to check the answers to these binary questions. In other words, your checks are now represented by a set of instructions that can be processed by a machine. So you then turn your questions into code. And then you must find a trigger to launch these checks, and then you must encode the trigger to automate these checks. And before you execute your automated checks, you need to know, or at least anticipate, the answers you expect, right? So you need to search for some heuristic principles or mechanisms known as test oracles by which you can identify problems based on the answers you receive from your software. And then you finally perform the checks. In simple terms, you execute your automated test cases. But that's not the end of the story, because after you performed the checks, you must read the bits, right? You must read the results. You must aggregate the results to be able to draw conclusions from these results. And to do that, you design reports based on what your stakeholders, such as your product owners or developers, what they need to know about the software to make their decisions, whatever these decisions are. And this, again, involves dealing with humans. And this, in turn, asks for dealing with tacit knowledge, as Harry Collins wisely put it. And then you probably want to have these reports created automatically, right? So you must encode these reports. And then you must observe these reports. And then you must interpret these reports that contain the answers to your initial questions. And you do that to determine the meaning and to judge the significance of the answers you will find in these reports. And then finally, you also need to respond in one way or another to what you have found in those reports to derive some actionable tasks. And through all this, you learn something new about your software product. New questions, of course, arise, and the whole story starts again. Now, that's, in my view, a typical testing lifecycle. Now, this implies that software testing is not just one specific activity. It's a set of activities. It's a set of activities you perform to evaluate your software, to make value judgments about your software. And you do that to figure out whether or not your software creates value for your customers. So doing software testing means performing many activities, as shown here, such as modeling, studying, exploration, investigation, automation, risk assessment, critical thinking, logical thinking, emotional thinking, stakeholder analysis, software validation, among many, many others. Now, this list is by no means complete. It could go on and on, possibly forever, but I hope you get the point. The point is that testing is not a mechanically one-dimensional activity, but a creative, human-centric and multi-dimensional activity. And so this implies that there is no such thing as automated testing yet, just as there is no such thing as automated programming or automated product management yet, right? And therefore, I prefer to talk about automation in testing, not automated testing. So the bottom line here is that the human testers and their skills are at the center of testing, not the tools. And so I'd like to conclude that essentially, to overstate the case a bit, all testing is exploratory in nature. And the good news here is that you don't need to be a bright mind or a super smart person to do that, right? Exploratory testing is not a talent. It's a set of skills that can be learned. So now let's see how we translate the approach of exploratory testing into practice. Let's look at least at the fundamental pillars of our technique. Now, from the bird's eye perspective, our technique contains 5 core components. And the first one is session-based testing. Now, what session-based testing does is very simple. It just takes exploratory testing and puts it into a straitjacket, as shown here. So it puts all the imagination that comes along with exploratory testing into a straitjacket. And by imagination, I just mean the ability to form new test ideas. Now, we put exploratory testing into a straitjacket for a simple reason, to make exploratory testing structured. So in simple terms, session-based testing is exploratory testing paired with project management. And we do that to scale exploratory testing, to allow it for larger scale implementations. Because the challenge is not to do that for 1, 2, or 3 teams, right? The challenge is to perform exploratory testing for 30, 40, even more teams in a large organization in a consistent way. So through session-based testing, we provide structure to exploratory testing. Now, the core object of session-based testing is the session. And the session is nothing more than a charted, reviewable, and uninterrupted unit of testing effort. And this testing effort is usually time-boxed. And the reason why we time-box our session is not just for the sake of time-boxing our sessions. We do that to cut our perfectionist tendencies during testing. And this just means that we want to avoid that we overcommit to a testing task. So we want to avoid that we dig into the same hole deeper and deeper, right? Because that usually happens when there is no deadline, as we all know. So for that simple reason, we allocate a fixed time frame of, let's say, 30 minutes, 60 minutes, 90 minutes to our sessions. And the core object of a session itself is the so-called session charter. And the session charter is just a short mission statement for our testing sessions. So in the session charter, we concisely, but also precisely describe what we should look for. That's it. So it helps us to focus our testing by doing 2 things, by setting concrete goals and by providing a clear testing scope. And to set the scope, or let's say to tighten up the straitjacket you've seen before of the session, we apply traditional requirements-based testing. And a requirement to us is nothing more than just a service we provide to our end users through our software products so that these end users can achieve their goals, whatever these goals are. So that's it. And so these requirements might be expressed as system use cases, for example, business use cases, features, user stories, epics, or themes. Take whatever you like. At the end of the day, these are all requirements. So all these artifacts express requirements on different levels and in different forms. And so we make use of them to limit the scope of our sessions. And we do that to make our sessions manageable. We want to make our sessions manageable, especially for unskilled testers. And the reason we are doing that is because the sheer functional and non-functional spectrum of our software products, is often so attractive that one gets so easily lost in their details, right? And while we are exploring these requirements, we don't just compare the actual product to its specification, we also compare the product to its product idea, to its actual purpose. So one of our core principles is not just to focus exclusively on verification, but also on validation in ISTQP terms, right? So we don't just want to ask if we are building the product right, we also want to know if we are building the right product. So we are concerned whether or not our software product actually meets the end user's needs. Now we do that because we know that our thinking errors often become software errors, especially when we aren't aware of our cognitive biases. So we already start hunting for these bugs during sprint planning or backlog refinement. And we hunt for these bugs literally every time we talk to our stakeholders, to our internal stakeholders, such as developers, product owners, or business analysts. And we also hunt for these bugs when we talk to our external stakeholders, to our customers or partners, for example. So we try to delve into their minds to analyze their thinking, because most of their knowledge about the software is in their heads. And this also includes their opinions, their assumptions, their expectations, their desires, hunches, feelings, or experiences about the software. So we are looking for bugs in the mind of people right from the start. And we are doing this by simply talking to them and carefully listening to them. That's it. And one method we are using to extract at least aspects of their thinking from their minds is BDD, behavior-driven development. Now, to us, BDD, I have to say, is not just a tool for test case automation. It's a tool we are using to create a shared understanding about our software. That's how we see BDD. So we are using examples in our conversations with our stakeholders to illustrate the behavior of our software from their perspective. That's it. And in doing so, we have learned that having these conversations with our stakeholders is so much more important than capturing these conversations in terms of Gherkin scripts, for example. And we've learned that capturing these conversations is so much more important than automating these conversations. Now, here is a simple reason why having these conversations with our stakeholders is so important to us. Imagine that this circle here represents what your product owner knows and thinks about your software. Well, then this circle usually represents what your product owner can put into words. And this circle is what your product owner usually tells you, for example, during sprint planning or backlog refinement. And this is what you usually understand. You see, there's typically a huge knowledge gap between what your product owner thinks and what you usually understand. So think of BDD as a tool, as a framework that helps you to close this knowledge gap through having conversations. That's it. And in these conversations, we are guided by questions. And these questions are mainly driven by our testing heuristics. Now, here's one example. This one is called RC by Karen Johnson. And this one is especially helpful when you are confronted with an ever-changing system, so to say. Now, here's another one by James Bach, Michael Bolton et al., so to say. And this one is called SFDPOT. And I think it stands for San Francisco Depot. That's the mnemonic of it. Now, this one is especially helpful when you're confronted with a new product in a new business domain. And there are many, many more heuristics out there. I don't want to discuss them all right now. Just take a look at them, try them out, and go for them. You'll find loads of information about those heuristics on the net. So the bottom line is that we are using these heuristics as a set of guiding questions that help us to drive the conversations with our stakeholders. So these heuristics help us to learn more about our software. They help us to close the knowledge gap between us and our stakeholders. So these are, in rough terms, our core principles that help us to limit the scope of our testing sessions and to perform exploratory testing in a structured way. Now, the next step is to set concrete goals for our testing sessions. And we do that by applying an approach known as tour-based testing. So a testing tour is not just taking a test case and calling it a tour, it's the entire metaphor. It's an exploration around a theme. And there are many different testing tours and schools of tour testing out there. Now, one of my favorite collection of testing tours is the one proposed by James Whittaker in his book, Exploratory Software Testing. I think it was released in 2009. And in this book, Whittaker describes a great variety of different testing tours, such as the supermodel tour, the museum tour, the FedEx tour, the couch potato tour, among many others again. So what these tours are doing for you is simple. They inspire you to set clear testing goals by forcing you to focus on very specific aspects of your software. For example, in the FedEx tour, the goal is to make sure that you have a consistent data flow in your application. That's it. A very narrow focus, but a crystal clear goal. Now, another example is the supermodel tour. And here you need to think superficially. Here, the main mantra is to not to think too deep, so to say, like the supermodels do, right? So for example, here, the goal could be to only try to reveal problems on the user interface of your application, not in the backend. Again, this just limits the focus. Now, here is an example that explains, I think, quite well why this matters. And this is explained in Whittaker's book. Now, imagine you want to go from Oslo to Stockholm. And what Google Maps suggested a few years back was a route like this. Well, you need to know that this bug went through hundreds of reviewers and nobody saw it. So the question is, how do we find these sort of bugs? Well, you might get lucky, right? Finding a bug like this. If you're doing, for example, manual checking, there might be some chance that some random neuron in your brain fires and gives you the insights to find this bug. But it's not good enough, right? We can't just rely on genius testers with Jedi instincts. And not everybody has those instincts to find these sort of bugs. So what does it take to find them? Well, it takes understanding about the application. Now, in that particular case, it takes the understanding that there can be black spots in the mapping data. It takes the understanding that there are places where the mapping data is just incomplete. And it takes the understanding there can be places where you have old mapping data connected to new mapping data. So in short, it takes knowledge. And if you then take this knowledge and focus on the boundaries of these black spots, well, then you will find these sort of bugs. And it takes preparation to gain this knowledge. So without preparation, you won't find these bugs. It won't happen. You might get lucky, as we've said, but who wants to depend on getting lucky? Not me, ladies and gentlemen, not me. So if you are looking for 10 different types of bugs at the same time, then you most likely won't find this one. And if you're looking for 3 different types of bugs at the same time, well, then you most likely won't find this one. But if you set specific goals by providing a clear focus, then you know exactly what you're looking for. And then you will find this sort of bugs. So all I want to say here is that tour-based testing in all of its potential forms is a powerful tool that allows you to set concrete goals for your testing sessions by providing a clear focus. So it will help you to find those rare, hidden, and subtle bugs that matter. And the reason why we do all that is to increase one single quantity. It's the quality of our software products. Or to be more precise, it's quality at speed, right? Now, I think everybody perfectly knows what speed means, but what the heck does quality mean? Well, to me, quality is just a degree of excellence of something. And the question then is, well, who measures this degree of excellence? Well, it's always measured by someone. And so Jerry Weinberg once wisely concluded that quality is just some value to some person who matters at some time. And this simply means that quality is inherently subjective. And as a result of this, different stakeholders will perceive one and the same software product as having different levels of quality. And the reason for this is that a bug is not necessarily within the software. A bug rather represents a relationship between a person and the software. And James Bach once brilliantly summarized this by saying that a bug is something that bugs somebody. So this implies that we must look for different things for different stakeholders, which essentially means that we must diversify our testing. We must diversify our testing to challenge the software from as many viewpoints as possible. And this leads us to our component number 4 of our technique to exploratory testing, which we simply call polychrome testing. I know it's a bad name, but polychrome just means doing an art of work in different colors. And that is exactly what we do when it comes to exploratory testing. We want to explore the software from as many viewpoints as possible to increase diversity, so to say, to account for the fact that there are many different ideas and many different opinions about our software. And in order to account for this, we apply a concept known as the 6 thinking heads. It's a concept by Edward de Bono, a Maltesian thinking guru. And this concept has been used for, I think, more than 20 or 30 years already to solve business issues in general. So it's not specific to software testing. So what is this concept about? Well, the core components, as shown here, are the so-called 6 thinking heads. And these are literally heads. And each head has a specific purpose associated with it. And that purpose is reflected by its color. And each color then stands for a certain viewpoint, a certain thinking direction. So when we perform exploratory testing, we aim, first of all, to invite multiple different user roles to our sessions. That means testers from other teams, developers, product owners, business analysts. And for each and every person, we provide a different head. So we don't just go for critical thinking, we also go for creative thinking, positive thinking, emotional thinking, and factual thinking to bring truly diversity in our approach to exploratory testing. And that is in rough terms what we do. So it's definitely a fun approach. Highly recommend to at least give it a try, because it definitely will make your testing more fun and most likely also more productive. And last but not least, we also apply what we call scenario-based testing. and this is just a fancy name of saying that every test idea we have during our exploration is documented. And the documentation of a test idea is what we call an exploratory scenario. I know it's not really the proper name for it, but it works for us. It's as simple as that. So here we apply different note-taking techniques to document our test ideas. We create mind maps, for example. We create product coverage outlines. We create different types of risk lists. And we also use several tools that help us to record at least aspects of our exploration. Another reason why we are paying so much attention to documentation is to make exploratory testing reviewable, because this then enables us to define the next test or even the next session in our session debrief sessions. Now then, that's basically it. That's our approach to exploratory testing from the bird's eye perspective. So when there's one thing I've learned in doing all that, then I would have to say that testing is not so much a thing you do, it's much more a way you think. So thank you so much, Michael Bolton, for reminding all of us about that. So testing, to me, is something that happens in our heads, not in our tools. And therefore, I like to treat testing as a thinking activity. And with that, I kindly invite you to also treat it like one. That's basically it. That's all I wanted to share with you. Thank you so much. Back to Bilur, back to the moderator.
Hi, thank you. It was a great presentation and you are just like in time. And we can take some questions if attendees have. I will also ask in Turkish, and also In between, I will get the poll questions. Just sorusu olan var mıydı konuyla ilgili? If somebody has a question, I'm also checking here the Q&A part. We can also do the poll. Let's look at the poll question. If you only had to choose one, which one would it be? Scripted test or exploratory test? I wonder what will our attendees answer. I'm also submitting here. Let's see. We have more than 120 people here, so we are waiting for the answers. I don't think anyone has any questions.
Bilou, it would be great if you could, check both of those radio boxes.
Radio boxes?
Yeah, in the question, because
okay,
it's as I've tried to point out, it's not about the one or the other. It's always about the both, right? Maybe I left the impression that I'm, against scripted testing, against mechanical confirmation of the software. That is definitely not the way I perceive it. I think it's a truly enabler. Tools truly enable, accelerate, simplify, enhance our testing. So it's not just about the learning part, it's also about the checking part. So if you can choose both.
Yeah, I wish we had this option both, but here most of the attendees said scripted test, but as you said, like it's almost half and half. So like, as you said, maybe we need both. Do you have any comment about this result?
Not at all surprising from my perspective. So it shows that that the answers might have been given completely randomly, because we almost had a 50-50 batch here. But it's not surprising to me. So I basically expected that. So I'm convinced that we have professional testers on the call here, and they know their subjects much better than I do. So I'm trust in their expertise.
Yeah, me too. I'm not a tester, so I need to trust also.
Yeah, and also if you let me to talk for a minute, I'm totally I agree with Ingo, but this is the, how can I say, dark side of those kind of debates. We force people to choose one. Normally, of course, we need to do both. Anything in software testing, as Ingo said, is a complementary activity. It's not a replacement. Like if we, I think exploratory testing is a replacement for scripted testing, we are in a wrong path. And I think he indicated that very perfectly. So I really feel the same. And it was a perfect session as always. Thank you, Ingo.
Yes, thank you, Ingo.